All right, so let's see how we can apply Venn diagrams to solve more complex problems. So we have an example here. In a class of 30 students, 20 students play tennis, 15 students play soccer. If each student plays at least one of the two, how many play both, right? So each student plays at least one. So we don't have a student out of the 30 who doesn't play either tennis or soccer. So all students are playing one or more of those sports. But now we're told how many play tennis, how many play soccer. What we don't know is how many play both tennis and soccer. And so that's what we need to deal with. So our information broken down now is there's a total of 30 students. Of the 30 students, the number of students who play tennis is 20. The total number of those who play soccer is 15. But the number who play both is unknown. And so we'll just call it X for now. We'll call it X for now. So now we then set up a Venn diagram. For our Venn diagram, we've got our universal set, and then we've got our set for those who play tennis, we'll call it set T, and our set for those who play soccer, we'll call it S. Now, if you look at the Venn diagram, right, we've got the intersection region here. The intersection region here represents what is inside the set of tennis players and what is inside the set of soccer players. So if a student is in the set of tennis players and also in the set of soccer players, that means they play both tennis and soccer. And so we're going to put our X here. This is where we have our X, the number of people who play both tennis and soccer. Now, if we go back to our data here, the total number of people who play tennis is 20. That's the total. So the total number within this set is 20. Of that 20, I have removed X and put X here. So I've removed X and put X here. So the remainder on this part here is 20 minus X, meaning the total minus what I removed and put there. Now, if we make sense of this, X represents those who play tennis and soccer, and 20 minus X will represent those who play tennis only, right? So these are those who play tennis only with no soccer. And these are the numbers who play tennis and soccer. So on the other hand, the total number of those who play soccer is 15. Of the 15, I removed X and put an X there, right? So the remainder on this side is 15 minus X. This is the number of those who play soccer only. Those who play soccer only. So we've got those who play tennis only, those who play tennis and soccer, and those who play soccer only. Now, what do we know? The total number of students is 30, meaning if I add up everything, I should get 30. So if I add up the number of students who play tennis only, those who play tennis and soccer, and those who play soccer only, my result must be 30. So I can write that down. I can write 20 minus X plus 15 minus X is equal to 30. Now, if I want to solve this, what happens? I'll arrange order of like terms. I'll have my 20 plus 15, right? Bring this X, bring this 30, this side becomes a minus 30. Then take these X's the other side, I'll get X plus X minus X. This will give you 5 is equal to X. So we found our value of X. Remember what we said, X represents those who play tennis and soccer. So the number of students who play both is 5. So there are 5 students who play both tennis and soccer.